Welcome back, everyone. Japan is not waiting for the future to arrive. It is building it now with the quantum internet. In Tokyo and several other cities, Japanese researchers and companies are already operating secure networks that use quantum key distribution to transmit data in a way that cannot be intercepted. This is not a prototype. It is a working system tested between banks, government offices, and research labs. With support from the National Institute of Information and Communications Technology, Japan is quietly creating the foundation for a new kind of internet that exists today. Japan is one of the few countries with a functional metropolitan quantum communication network in daily testing. The Tokyo QKD Network is a live project connecting locations such as government buildings, banks, universities, and telecom centers using quantum key distribution. These quantum links are not theoretical. They are being used to test real encryption, interoperability between different companies, and system reliability in urban conditions. By layering quantum keys on top of conventional fiber optics, Japan is extending secure communication methods without replacing existing infrastructure. These connections allow testing in realistic urban conditions using actual data transfer patterns. This network allows for secure data transmission. By leveraging the principles of quantum mechanics, the Tokyo QKD Network is setting a new standard for cybersecurity in the digital age. At the core of this system, we find quantum key distribution. This is a technique that uses particles of light to share an encryption key between two locations. If anyone tries to intercept the transmission, the quantum state of the particles is disturbed, and the intrusion is instantly detected. This means that quantum key distribution isn't just secure in theory, it's secure in practice, making it nearly impossible for hackers to eavesdrop without being noticed. That's why it's considered the gold standard for protecting sensitive information in the quantum age. In Japan's current setup, QKD devices are installed inside server rooms, often connected to routers in financial institutions and research facilities. These systems then share quantum-generated keys that are used to encrypt the data flowing through normal internet cables. One of Japan's major strengths is its collaboration across sectors. The National Institute of Information and Communications Technology leads development, but private firms like Toshiba, NEC, and Mitsubishi Electric are building the hardware. These companies have already deployed QKD boxes that fit into standard telecom racks and can operate alongside traditional networking hardware. Japan's universities provide the research backbone, especially in areas like quantum memory and multi-node switching. The cooperation allows Japan to scale and test technologies across multiple environments, from high-speed rail stations to disaster response centers. Universities also foster collaboration between students, professors, and industry experts, driving innovation in quantum networking. These partnerships accelerate breakthroughs, ensuring that Japan remains at the forefront of quantum internet development. The Tokyo QKD network is designed to test how quantum encryption performs in real life. It includes dozens of nodes connected in a mesh, meaning that data can travel through multiple paths depending on the load and availability of quantum keys. This mesh design boosts resilience. If one path fails, the network automatically reroutes data through another secure channel. It's a real-world testbed for how quantum-secured networks can stay robust, even during outages or attacks. Combined with fiber networks on the ground, Japan is developing a hybrid model that uses both terrestrial and satellite-based quantum systems in parallel to ensure broader coverage. A key innovation from Japan is the development of multi-vendor interoperability. Unlike systems locked to one manufacturer, Japan's network includes equipment from different suppliers working together. This is a major advantage in scaling a national system. Japan's quantum internet efforts are not limited to ground-based cables. Researchers are also working on satellite-to-ground QKD using photons transmitted from orbit. The NIC-T has already demonstrated successful quantum links between low Earth orbit test satellites and ground receivers. These links are meant to create secure communication between islands and remote facilities, expanding the reach of quantum communication without relying on ocean cables. Japan is beginning to introduce quantum-secure applications in critical areas. Some banks are now testing quantum encryption for daily transactions. Power utilities are beginning to investigate how to use quantum key distribution, or QKD, to protect grid control signals. Hospitals are exploring quantum-secure networks to safeguard sensitive patient data, while government agencies are piloting quantum encryption to defend against cyber threats targeting national infrastructure. Japan's quantum internet ambitions are not just about national pride or technological leadership, they are about shaping the future of global communications. By collaborating with international partners, Japan is helping to set the standards and protocols that will define the next generation of the internet. This means new opportunities for education, business, and innovation, not just in Japan but worldwide. The quantum leap Japan is making today could soon connect the world in ways we can only imagine. In the United States and Europe, progress is also accelerating. The United States Department of Energy has created a quantum internet blueprint and established testbeds in cities like Chicago and Boston. Private companies such as Amazon, IBM, and Microsoft are investing in quantum network protocols that can integrate with cloud computing. The near-term goal is to create practical, secure nodes for real-world pilot programs. Across Europe, countries like the Netherlands, Austria, and Germany are actively testing long-distance quantum links between laboratories and data centers. Most of these initiatives involve academic and commercial partnerships, and the aim is to achieve small-scale deployment within the next 5 years. The Communication Infrastructure Project is anticipated to connect quantum testbeds throughout member states, forming a continent-wide encryption network. These zones won't replace the classical internet, but will layer quantum key distribution over existing systems. This approach is designed to safeguard sensitive communications like those in defense, banking, and election systems from potential future quantum decryption attacks. Imagine a future where quantum key systems are as ubiquitous as firewalls, silently protecting our data, seamlessly integrated into everyday business tools. This future is arriving faster than you might think. In Japan, quantum-secure communication lines are already linking major cities, moving beyond laboratory experiments and into the heart of daily operations. Banks, power grids, and national infrastructure are now benefiting from quantum-level security, shielding critical data from even the most sophisticated cyber threats. What was once cutting-edge research is now foundational technology, quietly powering the systems that keep society running. Japan's unique approach is driving this transformation. By combining advanced hardware, open standards, and strong collaboration between government, industry, and academia, Japan is setting new standards for secure communication. The quantum internet here isn't just a vision, it's a reality shaping the way information is protected for generations to come. While other countries are still planning, Japan is already transmitting real data with quantum protection. As global interest in quantum internet grows, Japan's achievements set a new benchmark for innovation. Thank you very much for watching. Please like and subscribe.